The vendors, normally they just send one guy out there for cost reasons, flight. On the team event and actually be in the space, we're able to pull measurements from the point cloud for them. For this is actually a reactor coolant pump, our total station, and spatial analyzer that we use for actually doing our position layout. We were utilizing them, grew them to an enterprise resource that supports all of our nuclear power plants, our natural gas industry, our coal plants, wind turbines, solar farms. From the models, we created 3D PDFs, the electric work order packages. They were going to have to take that cutoff piece, if there was enough left, weld that back on, have all the QC weld inspections from root pass, hot pass, caps, that discharge elbow, that setter Z elevation height, which told us where our sole plate needed to be. The nuclear industry, if you extend an outage by a day, it's about $1 million in lost generation revenue. So, Tom Myers, I'll be speaking about Beyond BIM, emphasizing the C, construction and virtual design and construction, utilizing scan and model data for project implementation. After we get through design, identifying all the interferences, the actual carrying out, the actual construction part of our projects. That's me and my hair pre-COVID. This is what COVID did to me. But I started out in, really even before CAD and BIM, I started as a manual draftsman, hand drafts, pencil on Mylar sheets and all that. Got into CAD, BIM with Pro Engineer, then also into SolidWorks over time. Mom and pop shop I used to work for was closing up, and I had a little one on the way. So I joined our U.S. Navy and was a nuclear operator, operated nuclear power plants on our carriers at San Diego. Got to land on a plane on one of our carriers with the cable stop. That's pretty impressive. I could tell someone about that in follow-up discussions. From there, went into nuclear commercial operation at one of our Duke Energy plants down in Florida. That plant reached its end of life and moved on to construction manager. Had some welding crews that were doing major projects for our nuclear sites, and had come across this small little metrology group that was formed for a mega project at the site. We couldn't bring enough vendors in to really support the needs of what the project needed all the time. So this group was originally formed and trained to support the needs of that for scanning and layout using laser tracker and total station. Took that team and realized its value. At the end of that project, they were wanting to do away with them. A lot of the other upper management didn't even realize what they had. I said, give them to me. I'll take them. I'll use them on my projects. Ended up growing them from there. I had the CAD, I understood the CAD aspect of it, but didn't fully understand the data capture and the back end. Learned that from them as we were utilizing them, and basically grew them to an enterprise resource that supports all of our nuclear power plants, 11 of those, our natural gas industry, our coal plants, wind turbines, solar farms. So, and then from there we even now support commercial, external, outside of our regulated utility. So now I'm Metrology VDC Manager for the group. We also work, our company has a UAV drone team that's based out of Charlotte Airport, and flex on some of you guys that have drone teams yourselves, but our drone team is a part of our basically our airline group. So our drone team also has a Learjet and some helicopters. So if you could beat that, I'd love to hear it. But they use the jet for flying around executives, and also they've also put some LiDAR on it. But the helicopters are primarily used for transmission inspections, and then the drone for detail inspections of the towers. But get into our utilization for BIM. Laser capture, as everybody else is utilized here or familiar with and have been learning about. But we spend all these funds into data capture, turning into 3D models, capturing tons of data, and one aspect that we, in this project here, was a HVAC replacement. Building was basically built around a lot of the HVAC units. They were designed to be life of the plant. Well, now some of our plants are going into life extension. And they're like, well, we have to replace these now, and it's going to be extremely difficult to even get these out. This was at the very beginning of COVID. We weren't allowing vendors on site. We're like, how are we going to be able to actually bring the vendors in for vendor bid events, walk down the actual project? So we went in, we actually scanned and did limited modeling of the actual environment. Then we did basically a virtual Teams meeting and virtually took them into the space. Hugely beneficial, a lot of positive feedback from it, because the vendors, normally they just send one guy out there for cost reasons, flights and all that. Well, in this, those groups are able to have their whole team of guys, are able to have their engineers and their planners, and on the team event and actually be in the space, we're able to pull measurements from the point cloud for them. We animated certain models to show them the interferences that they were going to have to deal with, possibly modify their HVAC designs to help limit us from having to replace some of the conduit or move it, because we were going to do this online in one of our nuclear power plants, and we don't want to shut them down. They shut down every 2 years typically, and it's for now about only 3 weeks. So we're going to refuel the entire plant. We're going to do major modifications, and you got 3 weeks to do it. This we're going to do online. There's multiple units, and we're able to shut one down for maintenance and replace it online. So in doing this, hugely beneficial. A lot of positive feedback from the vendors that, I mean, this image right here, you were really only able to get 2 people up there. So if you had a whole bunch of vendors, you weren't even realistically going to be able to get them up there. So they have much better vantage points. They were able to take screenshots of whatever they were needing. This also really loud environments. Nobody was really going to be able to hear anybody anyway. So big plus on this. So when we get into 3D modeling, take our scans, turn into 3D models like a lot of us do. We reverse engineer components. For this is actually a reactor coolant pump inside a steam generator cavity. There's a part down at the bottom where a lot of the twisted tight piping is. It's basically a motor stand. That's a 6,900 volt motor, and that stand is about 7.5, 8 feet tall. We needed to reverse engineer that in place. Next time they were going to take that out was to replace it. So we had to scan it. Site didn't trust their drawings from the 70s that was highly accurate, and it definitely wasn't. We found some serious issues, did interference studies with the new design of it going in. We were able to support lifting and rigging plans of just about all that equipment needed to come out. Platforms, ladders, a lot of the piping, all needed to be lifted out of the cavity so they can eventually pull that part out. We also, from the models, we created 3D PDFs that we handed over to our craft teams, and they had iPads out in the field, and so they had their electric work order packages, also the 3D PDFs, so they can hide components, and when part of this was taken apart or coming back together, night shift, day shift, could see what was supposed to go where, because some of these are just lots of prefab twisted pieces of pipe and what's the orientation. So having that 3D model in the field with the craft, hugely beneficial. Material properties, having eye properties. We model an Autodesk Inventor because we need to know exactly, we can't have, I guess, the auto modeling aspect of it. If something's a deviation from what it was actually designed, we need to know that because quite a bit of these are really tight fit ups. So we go through all the scan and modeling, and then when we actually get to implement, we return to outdated methods of tape measures, plumb bobs, and handing a lot of the teams 2D drawings. But why? We've invested all this time and money into creating all of this, doing interference studies, and then for people to go out and pull tape measures off of column lines that are not actually where they're supposed to be by drawings. So how many people in here trust blueprints of the facilities that they've come across? I don't think I've ever seen a hand to that question. And like, why is measure twice, cut once such a well-known phrase? So the effects of errors just cost exponential amounts of money to a project. I'll speak to that a little bit later. And trusting the data of your drawings. So implementation, prefab, mock-ups. In this instance, we were going to be replacing a transformer on the far right, and as well as installing a deluge system, fire suppression system around the transformer. We were able to take the design from one engineering firm that was designing the deluge, the transformer model from another vendor, as well as the site scans and models of existing as-built, existing pads. Some of the stanchions we're going to move for the new design of the deluge to fit around a different format transformer. The weld crews fabricated up all the deluge system, and then we mocked up the actual deluge system using our total station and spatial analyzer that we use for actually doing our position layout. So we were able to orient, make sure the whole deluge system is set square, because in those outages we only have like 3 weeks to actually remove a 1 million pound transformer, put a new one in, fabricate the whole deluge system around it, connect all the electrical connections. By prefabbing and mocking up that entire deluge system, all the craft were able to pre-mark where all the U-bolt connections were able to go, make sure everything was square and set, so that when they go to set it up in the actual field, fabrication was significantly faster. We basically halved the time of install of the deluge than in a previous outage of another transformer. In this one, also cut lines, live alignment. We did that with the transformer as well. But right here we had a feed water heater, and come over here real quick. Right here, right there, and up there. Big, large bore pipe that we needed to fit in prefab. They needed to, once we oriented the heater, we needed to provide them cut lines for those pipes. The existing as-built or the existing plant connections, when they cut those, they actually had cold spring in them and they moved. They weren't going to basically put that stress back on the pipe, so they wanted us to factor in where the new location is, and incorporate any bevel necessary to meet up and provide the 3/8 weld gap necessary for those piping connections. We, in one of those instances, we had gotten all the measurements data set for us to actually perform the marking, and come in and I see one of the pipes has already got a mark on it and they already started grooving the pipe for cutting it. I call up my day shift guys. Where did you guys said you didn't lay out any of these pipes yet, right? And no, we didn't do any of that. One of these pipes is already cut and grooved. So called up the project team, chewed out a whole bunch of people, said, you called us in here to do a specific job, provide you this information. And they said, well, tell us what happened. Go out there, and I said, bad news, you're 1.25 inches off from where you should have cut it. Good news, you guys were wrong on the long end. So there was room inside of that pipe, and there's only one of each of these. This is for nuclear. If they had cut it short, they were going to have to take that cutoff piece, if there was enough left, weld that back on, have all the QC weld inspections for the root pass, hot pass, caps, which would have extended the outage. This is critical path for this outage, and ballpark for the nuclear industry, if you extend an outage by a day, it's about $1 million in lost generation revenue. Not including the cost of maintaining all those extra 1,000 resources on site besides the normal on-site resources, which basically triples that. So ballpark about like $3 million a day if they had been wrong. So they said, okay, we'll just wait until your marks are on there. They just wanted to get ahead in the project. Another implementation alignment aspect. Down there we had a ring that discharge elbow would sit on. Took a laser tracker in this instance. Got measurements of the horizontal connection of that discharge elbow that set our Z elevation height, which told us where our sole plate needed to be, and we were able to level that ring. We were given a 3,000ths tolerance. We were able to leave them with a thou and a half is the worst out of tolerance that we ended up leaving them, and we did about 6 of these pump replacements. And I'll open it up to any questions anybody might have.